Time to take what we know about limiting reactants and have learned from using the lasso method and extend this to a slightly more mathematical approach. We're again going to be working in your notes packet on page 3 and still working on objective 10K, the ability to determine the limiting reactant in a chemical process and solve stoichiometry problems involving limiting reactants. As we look at the next example problem in your notes, we can start to see the limiting factors of the lasso method. While it was very easy to draw pictures and use the lasso method when we had nice whole numbers, a situation like this, with 3.8 moles of nitrogen and 7.4 moles of hydrogen, becomes a little bit more difficult to represent in a lasso method sort of way. Now, it's not really impossible to do this. In fact, I've seen people use the lasso method on more complicated problems. We could very easily upscale by 10 and imagine that we had 38 moles of nitrogen and 74 moles of hydrogen, draw 38 nitrogens, 74 hydrogens, use the lasso method, and divide our answer by 10 when we got all done. However, that might not be the best overall approach to solving the problem. So I'd like to teach you a more stoichiometry-based, mathematical way to handle limiting reactant problems when we're working with numbers that aren't quite as neat and tidy.
We need to know how many moles of NH3 can be produced from 3.8 moles of N2 and 7.4 moles of H2. Sad face. You are going to learn to not like seeing the word "and" in your problem step, because that means that more work is coming your way. Well, what are some things we know here? The information we're going to need to do this, we're going to need to know that for every 1 mole of nitrogen, it will require 3 moles of H2 to use it all up. And for our other piece of information, I'm going to leave a blank because ultimately the information about the limiting reactant has to go in there. But we will need a relationship between the limiting reactant and the moles of NH3. When you get ready to solve the limiting reactant problems, there are a couple ways of going about this. We've used one method already, where we would use each amount and then find out how much we could make and pick the lesser of the two amounts. There is a second approach to this that is also useful. I don't have a real strong preference in terms of which one you use, but I do want to show you the other one. The other approach is essentially to pick one reactant and figure out how much of the other it's going to take to use it all up. And it doesn't matter what you pick. Let's say you choose to go from moles of N2 that I have to moles of H2 that will be needed. That will let you pick your limiting reactant and ultimately go from moles of limiting reactant to moles of NH3. Here we go. I have 3.8 moles of N2. If I wanted to use up all of that N2 for every 1 mole of N2, I would need to provide 3 moles of H2. Now we have to find a calculator. So I need 11 moles of hydrogen if I want to use up all of my nitrogen. moles of hydrogen. I don't have enough. I can't possibly use all that nitrogen because I haven't got enough hydrogen to go with it. So my hydrogen is going to be my limiting reactant, and if I go back up here, I can put in my 3 moles of hydrogen, and now I can solve my problem. This becomes irrelevant. I need that number. 7.4 moles of H2. For every 3 moles of H2 I put into the reaction, I will get 2 moles NH3 out of the reaction, and I can figure out that 4.9 moles of NH3 will be produced. That's going to be our general approach to limiting reactant problems. Now, let's look at what steps are going to be involved here. Step 0 for limiting reactant problems is to grumble. If you grumble in your head, you can use whatever words you want. If you're going to grumble out loud, try not to do anything that'll get you in trouble at school. Limiting reactant problems are a pain in the patoot, and I know that. So step 0, you grumble. But the sooner you stop grumbling and the sooner you get to work, the sooner it will all be over. So step 1 then, if you don't already have each reactant in terms of moles, put each reactant in terms of moles. Usually that's a grams to moles conversion, but we know there are other ways that this can happen. Step 2, find the limiting reactant. I said that one way of doing that was to choose one reactant and then calculate how much of the other is needed. It's that have-need comparison. Once you know your limiting reactant, you can do moles of limiting reactant to moles of product. And then go from moles of product back to the amount of product in whatever way it's requested. That might be it's requested in grams or milliliters or liters or however the problem wants that amount output. You take your moles of product and go back to your amount of product.
Now you can proceed to your turn problems and try limiting reactant 2 problem, the one that deals with mole-to-mole relationships.